Okay, what I have here for these problems is we do not have equal bases. So what we're going to need to do is we're going to need to rewrite it as a logarithm. So if I rewrite it as a logarithm, you can recall my base is 4. So I have a log base 4. And then the other two numbers switch places. The base stays put, the other things switch. So the 20 gets put right there with the log, and the x gets put over there by itself. Now the truth is, at this point we are done. My answer is log base 4 of 20, x is by itself. I am done, but we also usually do want a decimal estimate. To get that, we're going to go to Desmos, and we're going to pull up our keypad, go to Functions, look under Miscellaneous, and choose the log with the base. The log in the middle is the one you're going to be using most of the time. So log base 4, go over into the parentheses of 20, is equal to 2.16, and we usually want 4 decimals, so that's going to be 2.1610, because that 6 would make the 9 round up. So to round up a 9, you have to change it from a 09 to a 10. So that would be your decimal approximation of that answer. It kind of gives you some context to what log base 4 of 20 actually means. Let's go ahead and look at another one. On this next one, I'm going to have this still doesn't have equal bases, so I have to rewrite it as a log. So this is a log base 5. And then the entire exponent switches places with everything on this side. So log base 5 of 62 equals 2x. Now at this point, I need to get x by itself, so I'm going to divide by 2. So the truth is, this is your answer here, log base 5 of 62 divided by 2. We do need to get a decimal approximation though. So going to Desmos, I'm going to once again pull up my log base. So get my functions back. Log base. Oops. It's kind of in the wrong line there, but we'll fix that. Log base 5 of 62. And then to divide the whole thing by 2, be sure you close that parenthesis and then do a divided by 2. If you don't close the parenthesis, it'll just divide the 62 by 2, which is absolutely not the same thing. So log base 5 of 62 divided by 2, and that decimal approximation is going to be, in this case, a 1.28, and that it's going to round up to a 2.2. So instead of 2.1, the 6 rounds it up to a 2.2, and that's how you do these problems. We might look at one more. I'm actually going to let you do that third one on your own, and we might glance at what the solution might be at the end of the video. On this next one, I'm going to go ahead and show you how to do it. This one, it says to isolate the base, in other words, get the base by itself. So since there's a plus 5 over with that base, I'm going to start by subtracting 5 from both sides. That's going to give me a 16 to the x minus 7 equals 16. And in this case, it just turned into something where I don't have to rewrite it as a log because the bases are the same. So I have x minus 7, and the understood exponent is 1. So x minus 7 equals 1. So that would give you a final answer of x equals 8. So sometimes when you start to get the log by itself, you find out that, hey, I ended up with equal bases at some point in the middle of the problem, and you can take that shortcut. If you did not take that shortcut, you still would have gotten the same answer, just would have looked a little bit different, but when you got the decimal approximation, you would have found out it really was just an 8. On one like this one, how you would start off on the next one is you would need to isolate by dividing that 2. So your first step on the next problem is divide by 2. I'll let you finish that out on your own. This last one looks a little special. I have an x stuck in the log. It's the base is completely isolated of e to the x. So remember, I just do a log base e, switch places of other things, of 2 equals x. Now the key thing to remember here is that a log base e is the same thing as an ln, or a natural log. So ln of 2 equals x. And if I want a decimal approximation, you can just type in ln of 2 in Desmos. If you have other questions, reach out to me via Zoom or email.